Good afternoon, everyone. This is Professor Maloney, and today I'm going to create a second Unit 3 programming example. This one is going to demonstrate set precision again, okay? Setw, meaning set width, setfill, getline, the power function, and a temperature conversion function. So there's quite a bit, and Unit 3 is winding down, so I want to make sure that I can get this done relatively quickly. So I've already typed everything in, and I'm going to first just kind of share the file, or show the file and talk about it. Then I'll just copy it and paste it into my REPLs, and then let you take pictures of it, as I always do. Alrighty, so I'm going to go ahead and stop showing me there and come on over here and share my screen. All right, share. All right, so now let me make sure that my recording is going, and it is. It looks like, yes, and I have got my mic on, yes, and I am sharing my screen. All right, so I'm going to come over here, get out of that thing there, hide that little thing there, and now I'm going to open up the file I was just talking about. So this file here, okay, is just some things that I put together specifically for Unit 3 to help you do what you need to do so that you can get your programming exercises 3.1 to 3.6 done in a satisfactory manner. All right. First thing, as always, you have to watch my Chapter 3 or Unit 3 overview video, right? I already played that in class. Most of you attended, but I said, you can watch it over and over again if need be. And I do have closed captioning on it so that you can just stop it. Those of you that need to read the text can read the text. Those of you that want to undo that can click CC from when you get to YouTube after you click my video, and then you don't need to see the CC if you don't want it. But the big thing is that it demonstrates, right? It's not just talking, it's also showing. But anyway, so Unit 3 overview was talking about the unit in general. Then I did a Unit 3 programming example a couple days ago that I shared with you guys using an in file and an out file. I showed you how to create an in file using a simple notepad text editor, and I then converted that file to, I used that file to create an out file, and I used a data file, a .dat file for that one. Okay, so this one, I'm going to do some of the other things in Unit 3 that I've talked about. So a little temperature conversion formula, very simple. And as I said before, when I talked about any formulas in this class, I said, if there's a formula needed on an exam, you will get it. And that's not just Professor Maloney, that's just generally what we do, because we're not testing you on the formulas. The class is testing you on using the variables that might be needed in a formula to make the formula do what we want it to do, but not teach you how to use, as an example, the Fahrenheit to Celsius conversion formula by yourself. I do that stuff in my head. I mean, I'm Canadian, and up there we use Celsius. So basically, the easy way is when it's 32 degrees Fahrenheit, that's 0 Celsius. When it's 50 degrees Fahrenheit, that's 10 Celsius. So it's 18 more than the first one, okay? And then 68 in Fahrenheit is 20 in Celsius. Add another 18, so 68 and 18 is 86. 86 is 30 in Celsius. Add another 18 and you're up to 104, which is 40 in Celsius. So they're easy things, but then if you want a specific number, let's say you wanted to figure out what 11 in Celsius is, and applying it the opposite way now to Fahrenheit. Well, I said 10 Celsius is 50. Each one is 1.8 degrees. I mean, doing it the manual way that I do. So then 51, instead of being 10, it would be 11.8. 52 would be 11.8 plus another 1.8. Okay, so 51.8, add another 152.8, add 0.6, it's 53.6. 68 is 20. So let's say you want it 70. So that's two more Celsius degrees to use in the Fahrenheit, Fahrenheit degrees to use for Celsius. So 68 is 20, but 70 Fahrenheit is 2 times 1.8. It's 3.6 more than 20. So it's 21.6. That equals 70. Don't worry about any of that. That's the whole point of what I'm trying to say here. You don't need to memorize any of that stuff there. But that's what I do just to approximate things. And I like to have fun with my little math periodically. So anyway, so I'm going to give you that, right? Okay, setfill, set precision, you've already seen. Setfill, I'm going to do a little example where I have a pound sign that will trail if there's enough characters left in a set width to accommodate it. And we're going to do a calculation using the POW function, so we need CMath for that one. And I'm going to use that getline. I talked about getline for like if you're wanting to use words and spaces in a variable. Okay, so, but I'm meaning in one variable. So full name will be my example today. Full name includes a first name. It may also include a middle initial, and it might include, well, it has to include a last name. All right, so that's that stuff. So here is the nuts and bolts. We know pound include IO string. Everyone in here knows that by now. It's your CIN, it's your COUT, it's your ENDL. It's also things like show point that I mentioned a class or two ago. That's technically in there as well. All right, so that's your IO string. IO manip is to use the fixed and the set precision and the setw and the setfill, which I'm going to demonstrate today. Pound include for CMath is to use the POW function. And remember, POW means power. So let me put in this another power function, right? Meaning 2 squared equals 4. That's 2 to the 2, right? 3 squared would be 9. That's 3 times 3, or 3 to the 2 power, okay? And then the pound include string, I'm using specifically to use getline and a variable called full name as it relates to getline in the string class, okay? All right, so we're going to start with our simple little deck. Of course, we always have int main, open and close parentheses, and an opening curly brace. The closing curly brace is always at the end of your program. So that's the closing. So everything is in int main. We will start using other procedures and functions that are outside int main coming up in either chapter, I think in chapter 5. It's possible to be chapter 6, but either way, it'll be coming up pretty soon. All right. Okay. So declaring variables. I'm calling one temp C. Okay. And I'm assigning it the value of 0.0. And this is for my Celsius temperature. All right. And then double temp F equals 0, 0. Again, just initializing it to 0 Fahrenheit temperature. All right. Then we're going to add fixed, show point, and set precision 2. So that's this statement. Cout less than. Remember, anytime we use cout, okay, or out file, you know, the OUT, in other words, you have less than. When it's input or in file or CIN, then it's greater than, like right here on SIN. Okay. All right. So anyway, cout less than, fixed less than, excuse me. Set precision 2. We want to just make sure that we're allowing 2. And technically, I didn't put show point in here, so I'm going to do that too, just in case we have trailing zeros. All right. So fixed, show point, and set precision 2. And then I can change this, and later on I will change it in this program. I'm going to do a file save of this thing now since I made a change. All right. So that's going to be to get the variables. The temperature in Fahrenheit is what the user is going to give us. And then we're going to convert that to the temperature in Celsius. All right. All right. So step 2, get the initial value of the initial variable temp F from the user. So we're just saying enter a temperature in Fahrenheit. That's the cout statement, right? That will appear on their monitor. And then we're taking their response with a C input statement, which we've done quite a bit in this class now. So CIN greater temp F. So temp F stands for temperature in Fahrenheit. All right. So assign the user's temperature choice to temp F variable. And then the calculations, and I say again, if this was on an exam, I would give you the formula. This is the formula. temperature in Celsius. So temp C equals, open parentheses, temp F minus 32, close the parentheses, divide by 1.8. Remember, when we use an open parenthesis and a closing parenthesis, whatever is inside those parentheses is done first based on the order of operations. So even though there's a division in this particular formula, the division is done after this because we are putting it in open and closed. So if I deleted this and deleted this, then what it would say is temp F, that's already been gotten from the user right here, minus this, but that's going to occur after this occurs, right? But I don't want to confuse you on stuff like that. Remember, the whole point was use open and close parentheses when you want something out of the order of operation, meaning outside the order of operations, to be done first. So we're going to take the temperature in Fahrenheit. I said 10 is 50, so let's say it's 50. So 50 minus 32 is 18. Then 18 divided by 1.8 would be 10, and 50 in Fahrenheit is 10 in Celsius. If it was 20, so this would be 68. 68 would be then minus the 32 is 36, and divide by 36 by 1.8, and we get 20. Okay, so that's that formula. All right, and then step 4, just display the results. Simple COOT statements again, displaying the output. So we're just saying, here's your Fahrenheit temperature, temp F, and here's your Celsius temperature, temp C. Okay. After that, I just want you to see, before I do much with set precision again and set width, the numbers 1 through 0, well, really 1 through 10, but just putting 0 as the 10th spot, meaning this is the first space, second space, 9th space, and this is the 10th space. So that in things like set width, when it says set width 4, that means it's setting it up with 4 character spaces, 4 spaces. Then depending on where I start that, it'll be easier for us to see them. So we're not doing anything with this other than just showing those columns to see basically position numbers. All right. Then we're going to have a couple variables here. One called num1. It's an integer, and I'm just assigning it as 3. I know we don't want to assign, but this is again just to demonstrate an example. We are letting the user give us the C input for the temperature so that you can have fun with that one, right? If you want to practice converting from Fahrenheit to Celsius. All right, so, and then we're making a double, but the dec1 for the double, I'm using 6 decimal places. So I'm just saying 23.1, 2, 3, 4, 5, 6. And then 2 more variables that are going to be used toward the end of the program in the POW. POW meaning power. Okay, now back to the Y example. And obviously I could have done this with doubles as well, but I'm just going to make this easy. So if you have 3 to the power of 3, the answer is 3 times 3 is 9, and it's the power of 3. So then times it again, times 3 is 27. So that would be 3 cubed. If you have 3 squared, it's 3 times 3, which would be 9. If you have 2 squared, meaning 2 to the 2, it's 4. If you have 2 to the 3, it's 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. If it's 2 to the 5, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Just simple for square roots and cubes, all right? All right, then we're using 2 examples with the set W, okay? And set W always have an open and a close, meaning you're going to have an argument in between there, right? So that's setting the width for your numbers, right? So, and you need the pound include IO manip for this one, right? So then a COOT statement saying, but before my COOT statement, I'm saying, so set W, meaning set the width off the columns to 4, all right? So now this num1 is in a column width of 4. So if I needed to type out, if I'm only typing out one number, like this number 3, it'll be in the 4th spot in this little thing here, up here, okay? Because the column is 4 wide, but 3 is only one number, and so therefore it It's not left justified. In other words, it's right justified. Numbers are right justified. Okay. And then the next one is dec1 for decimal 1. And decimal 1 is this dec1 value here. So it's this. So in this case, we have 6 decimal places. All right. So I'm going to show you what that does. All right. And then I'm going to do it with set width of 8. Meaning in this case, it could take, 1, 2, 3, 4, 5, 6, 7, 8 characters for an integer if we wanted to. But again, we're using the same number 1, just that thing there. So it's going to show a 3, but that means the 3 will be in the 8th position up here. Okay, up in this thing up here. All right, so the 8th position. All right, and then dec1 will be the same thing, 23.12345 But what you're going to find is that I've already set up here my coot with set precision of 2. So that overrides. Set precision is the boss if it's going against set W. So that's what I'm talking about down here. And I'll just demonstrate this as I get to it, okay? And then I change my set precision 2 to set precision 6. So you see what then happens, because again, set precision is the boss. So if you have set width of 4, but set precision of 6, well, that'll still override. You'll take more than 4 characters. If you have 8 here, but you do set precision 12, which I do down below, okay, so set width of 12, everything is based on the boss, okay, in terms of what shows. And then this one is a setfill example, right? So we do that with a coot and then setfill. And setfill in this case is one of the few examples where everything is lowercase, both set and fill. It's one word, though, as setfill. And when you have the argument here, and then it's because it's a char, setfill is based on a char character. So a pound sign is what we're going to be doing, adding it to every unused character space. And this is trailing, meaning on the first places, the first, let's say 1, 2, or 3 up here. So let's say we had used, this is a 10. So if we had a number that needed to take 7 of these characters, so the 7 numbers would be over here from 4 to 0. And then the 1, 2, 3 would have pound signs if that's what we wanted to do. And I'm demonstrating that here somewhere. All right. Okay. And then set W for 12. Oh, so the set W for 12 is with the pound. Okay. Not whatever I just said a minute ago. And I'm taking dec1. So dec1 is the decimal 1. It's 23.123456. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, right? 1, 2, 3. Up here I'm at. Okay. So that's 9 characters. 23 is 2, the dot is 3, and then 4, 5, 6, 7, 8, 9, which means down here there's 3 spaces available, and those spaces will be the 1, 2, and 3 where I did this. Okay, so 1, 2, and 3. So they'll be pound signs. All right. Okay, then I'm doing the POW function. Oh, sorry. Then I changed it back to set precision 0. So I'm demonstrating a set precision with 6, also with 4, and also with 2, and with 0, just to give you a lot of those examples, because every program in chapter 3 or unit 3, or at least half of them, want you to do something with set precision. So just to sort of help you get used to it a little bit more. All right, and then a POW, and again, remember POW is power. Do POW function example. I don't want to. I want it on one line because I already have too many things taking up too much space. Function example, which is x2. I'll just say power. There's a there. Okay. All right. So then here we're going to have somebody enter 2 integer numbers entered separated by a space, and then this is going to do the POW function. So again, if it was a test, I would do this for you, meaning I'd give you the formula. All right. All right. And then after the POW function, then I'm doing the getline. So here I say enter your first name and a space followed by your last name. Or you can do your first name, middle initial, if you happen to have a middle initial, a period, then another space, then your last name. Or if you're a Catholic like me, you can have your first name, your middle name, your confirmation name, and your last name. So you can put in 4. It doesn't matter, because now we're going to have a variable called full name, okay? And full name is going to use getline, and getline will take whatever I type in and return it as full name. All right? All right, so this one here, let's talk about this one a bit though. So we're entering your first name, we're saying, and a space followed by your last name. So we're not saying middle initial, confirmation name, or maiden names, or any of those things, just two names. But it doesn't matter. You can type in anything you want if you then code it. And obviously, I'm going to let you take pictures of this. So declare variables, and we're using string full name as a variable. And then we're going to use that with getline to allow spaces in the string. No calculations down here on this part. And then show full name as the output. Now, I've got this cin.ignore because technically getline has two arguments. The way I'm doing it, getline open cin, comma, and then a real variable name is not really the way you normally do it. Okay? Normally you have what's called a stream size. That's because you might want to limit how many characters can actually go in this full name variable. But I don't want to make things too hard for you, because this is all you need for chapter 3 or unit 3. So as long as we type cin.ignore right here, then this statement will work. Otherwise, this statement won't work. All right. And then your name is full name. All right. All right. Now let's go ahead and put this into REPL. All right, so control copy that to my file save. Right. Now I'm going to go over to REPL, already open for us. I'm going to create a REPL, okay? And I want C++, and I'm going to call this unit, I think I usually call it chapter. Chapter 3, not a text file, no, chapter 3, I'm going to say setw, comma, setfill, comma, setprecision, comma, because they have open and closed. Getline, how, and temp conversion. A lot of a name. Let's see if it'll take the name. Yes, no. Well, you know what I'm going to be doing. Let's see what they're wanting that to be. Let's see if that might be the comments. I'll just get rid of everything I can. May also just be the size, how many characters or words or whatever's in it. How this thing, and I'll just say temp conversion. See if this will take. Man, they should give me an error. They're saying it's too big or too many whatevers. Okay, so anyway, there it is. All right, I think I already copied it. Did I or did I not? I did. So now let's go over here and delete this thing. Okay, and Control V are what I just did in. Okay. All right, so now I shall run it. Okay, so they're asking me to enter a temperature in Fahrenheit. Now, before I do, let's look at what I've done. We know the pound includes are up here in lines 3 through 6, right? Pound include for IOStream, for IOmanip, for CMath, and for string. IOStream allows us to do our CIN, our COUT, our ENDL, and our show line. Okay. IOmanip allows us to use fixed, setprecision, setw, and getfill. CMath allows us to do the pow function, the power function. And string allows us to use getline and to use strings in general. And namespace standard is obviously for the CIN, COUT. Oh, sorry, I think I said that up here in IOStream. IOStream is obviously the library that allows us to use all sorts of basic input-output features. And then the using namespace standard, std, is what allows us to use specifically CIN, COUT, show point, and ENDL. All right, so we've declared variables, so nothing's happening yet. Declared variable, nothing happening yet. Here is the first thing that you need to note in terms of what's going to happen. So we're putting a COUT statement, but this does have code, right? Fixed, show point, and set precision. Set precision, I told you, is the boss. And it's actually the boss of a lot of things. I'm going to be using it down below with set width, but set precision is the boss, meaning whatever happens in set precision is more powerful than most other things. So what is this going to do? Well, it's going to give 2 decimal places for every double, meaning every decimal place number. So if for an integer, it won't do that, but for doubles, it will. All right. So in other words, if I enter a temperature now and I base it on a whole number that I input, it'll still put that number with a .00 afterwards because of line 16. Okay. All right. And then I'm putting the COUT statement, enter a temperature in Fahrenheit. So you know we're going to see that. And then you're going to see the CIN temp F. That's where I'm capturing whatever I input. Okay. Then we're doing the formula. So the formula is going to be based on temp F, which is what the user is giving us, and that's Fahrenheit. Okay, but I'm calling it temp F. And temp F is what I type in, or you when you code it, minus 32, and then divide that by 1.8, and that's Celsius then on the left, the temp C. Okay. And then here are the next 2 things that we actually see on the screen, the current temperature in Fahrenheit, temp F equals temp F. But here, temp F will have 2 decimal places because of set precision 2 right here. Okay? All right, so let's do that part now. Now, remember what I told you? In Fahrenheit, the number 50 is 10 in Celsius. So I'm just going to give us an easy one at the beginning. So that 50 is 10. 68 in Fahrenheit is 20. 86 in Fahrenheit is 30. 104 in Fahrenheit is 40. So I shall use 30, which is 86, right? So 86 will come out as 30, right? So now the current temperature in Fahrenheit equals 86.00. See here, that's this line here. That's where we are right now. So temp F, remember, is a double. Right up here, that's a double, okay? But because of our COUT in line 16 with set precision 2, this double temp F is going to show with 2 decimal places, even though you see I entered it right here as 86. That's what I entered right there, okay, 86. But because of set precision 2, all right, and the fact that it is a double, then it's going to display it with 0.00. And similarly, the answer, which wasn't typed in, obviously, because the formula is doing that, is 30 based on what I told you. The temperature formula is down here in line 23. So that's why I used easy ones to give it to you like that. But let me tell you now, though. So if I want 1 more degree in Celsius, okay, then I have to make the change, obviously, in Fahrenheit. So I said that for every 10, basically, it's 18. So again, you don't need to worry about any of that. But if I put the number in Fahrenheit of 87.8, that'll be 31, exactly 31. So let me run it again. Stop it. So I'm going to say 87.8 this time, and it'll be 31. 87.8. Enter. And it's 31, but again with 2 decimal places. Anyway, that doesn't matter, right? But it's there. So now we see that. Okay, so now that takes us to these 2, the current temperatures, which are the COUT statements, right? That's these 2. So now we're down to 26 and 27. Okay, now right after those 2, I say a COUT statement to just display 10 digits, not numbers, because technically 0 should be 10, but I want it to only display 10 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 are the first 10 little characters, so that now when you see the number below it, 3, see it's at spot 4. The next 3 below it is also on spot 4. The 23.12 doesn't matter. It's not really in spot 6. It's because there is, let's go down to the next one. So that's the COUT statement showing, or typing out 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Then I have my declarations for the next variables. Num1 equals 3, and dec1 equals 23.12345.6. So that's those. Then we have to go down to where we're going to display it, and that's here. And now it's lines 38 and 39. Okay, so line 38 starts with set width of 4, and that's why I got this 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this number, num1 equals 3, but in terms of characters, it's only 1, right? It's the number 3. So since this set width, set w, is 4 characters wide, and numbers are always right justified, the number 3 is in the set width 4 position, like the highest position, because it's a small number. So had I typed 1, 2, 3, 4 as this number, it would start at 1, and the 2 would be under 2, the 3 under 3, and the 4 under there. If I did 33, then the 3 would be under the 3, and the second 3 would be under the 4. I'm just saying, in other words, 1, 2, 3, 4, okay, is set width 4, and because num1 is being applied to it, and it's only 1 character, it does this, all right? But now, this is the part I want you to look at, and I'm doing it 2 different ways, and I'll kind of walk through both. But this is first 23.12. Why is it 23.12? Look at the number. It's not 23.12. It's 23.12345.6. That's a huge difference, okay? But you know why it's 23.12. It's because of our coot set precision, not coot, sorry, the set precision 2 in the coot way up on line 16. So set precision 2 is the boss. It overrides the set width of 4. It doesn't care about anything. It's going to give us 2 decimal places after whatever the number is. So it's going to have the start number, the decimal place, and then only display 2 afterwards. All right, that's what it's going to do. So go back down here. And that's this one. So, okay. So the first part of it displays the 3 in spot 4. And then you see there's a space right here after num1, meaning after the 3, there's a space, and that's exactly 1 character. So that's a space of 1. And then dec1 comes out. And dec1, by the way, is also under set w, even though you don't put set w over here too. If you do a set w, everything until you change it is set w, okay? But again, dec1 is going to be basing itself, on set precision 2 up in line 16, because that's the boss, okay? So that overrides set w. So we get 23.12, not 23.1, okay? All right, then the next one, coot set w, num1 again, and dec1 with a space, but now it's set w8. So that's this one. Okay, so there's the 3, and look at it, it's underneath the 8, right? Why? Because set width is 8 characters, but 3 is only 1 character, and it's always right justified. Numbers are always right justified in every programming language, even in Excel. Everything is right justified if it's a number, okay? So by default, and you can format it though in your output with strings, and then you can left justify it, but anyway, by default. So 3 is over here under the 8, and then 23.12 is now really under set W8, which means this whole number here, let's see how much of it could take. 1, 2, 3, 4, 5, 6, 7, 8. It could really go up to 23.12345 in terms of characters, okay? But the answer is 23.12. We're up here. We're not down at this one. We're up here because it's still under set precision 2. All right? So that's that. Now, I'm stating here that, well, I'm sorry, I've got those 2 done. All right? Now I'm saying to show all columns in set W, meaning the available characters, we need to change set precision. So now if I make set precision 6, okay? So now it's 6. And you notice, technically, again, I don't need fixed, I don't need show point. I say set precision is the boss, and it is the boss. But this means 6 characters, 6 decimal places, sorry, 6 decimal places. And then this line 43 and line 44 is exactly this line up here. this one here, 3839. It's just, again, me copy paste, right? But my point is that now, though, I changed the set precision, so now you're going to get different outputs. So down here, the 3, I'm on this line now, okay? So the 3 is still column, character 4, because that's this one, sorry. So I'm on 43 right now, okay? So that is this one I'm hovering over. So the 3 is character 4, because it's only one number, and it's 4 wide. Then I'm putting a space, and then deck 1. But see, now deck 1 is 23.123456. You might say, oh, but, Professor, you said it'll now go to 23.12345. Yes, I did. But I also said, though, remember, set precision is the boss, and that means 6, and that's 6 decimal places. So no matter what we have in our little set width, this comes out at the end, okay? And then for column with set width 8, same thing, the set width 8. So we have our little number 3 under 8, as we did in the first 3 examples now, we'll say. And then 23.123456 still shows up because set precision is set at 6 in this line here. Okay, so until we change set precision, now everything would be coming out at that number. Okay, so that's done. Now I added setfill. Okay, exactly underneath that, there's a new coot, and it's saying setfill $, okay? And then I'm going, so that means now that until I end it, okay, or change it, there's a setfill. And with setfill, what we're doing is we're putting a character. It's got a single quote because it is a char. By default, it's a char. So you can only put one character, but anytime you use a char, you need a single quote before it, and a single quote after it. Kind of looks like a face, right? But anyway, so single quote, then the char you're using, which is a £, and then a single quote. And then all that really shows, obviously, is the pound. Okay? All right. So down here, you see we have pound, 23.123456. So this is based on our set width. It is 12. If I made this 14, there'd be a couple more pound signs. If I made it 10, there'd only be one pound sign. Okay? So that's what that is doing. Then I can't, the very next coot statement, I'm making set precision go back to 0. Or not go back, because we started with 2. I'm putting it at 0 because I'm now going to be entering integers, and I don't want the user to type in, let's say, 2.3 and 3.7, because my math is not that good. But I can sure do 2 to pretty well anything, and 3 to quite a few things. But you're just knowing simple math for that. All right, so then it says enter 2 integer numbers separated by a space to demonstrate the power or power function. All right, so I shall say 3, and I shall say 5. Okay, so what is 3 to the power of 5? Well, all you do is use your hand to count. So 3 times 3 is 9, that's 2. 9 times 3 is 27, that's 3. 27 times 3 is 81, so that's 4. 81 times 3 is 243, so that's 5. Okay, so the power of 3 to the 5 is 243. So that's what the pow function is, all right? And what is the formula? This is the formula right there, line 57. It's pow, open parenthesis, x comma y, but the way it interprets this, it's the same as saying pow to the x, and then a superscript of y. Superscript means like it's a square or a cube, you know, where the y, in other words, would be higher than the x. Not higher. Position-wise, it would be higher. I did it in Word. Let me actually just open a silly Word file. This is for you guys, but let's see. I can go down here. Okay, let's just type in x to y, right? Now, if I select the y, and I go to, is it home? Where's superscript in Word? I don't even know. Let's see. Superscript, okay, superscript, okay. See, that's what it's really doing, and let's make this now a big font. Okay, so if we did 2 squared, it makes more sense than xy. So let's make this a 2 and then say to the 4, oops, let's see, 4, make this superscript again, that, okay? So if that helps you, it's 2 times 2 times 2 times 2 is what that means. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4 is 16, right? Okay. Anyway, so that's what that one does. And now we're at the last bit. So here, string for full name. You might say, why are you putting some of your variables way low, Professor? It's because I'm trying to treat each one as a separate little program, okay? So, but you know, obviously I got the same pound includes, I got the same using namespace, the same int main. I don't want to go make 4 separate programs for you guys though. You know, for this thing, I'd rather just demonstrate it this way. So in some cases, I put the step 1, 2, 3, 4 just to do it again. So anyway, string full name. All right, so I'm saying we're going to use it with getline to allow spaces. There's no calculations. And for display, we're going to show full name as output. Now, this cin.ignore is important. If it's important for your test on the 28th, which is 8 days from today, which is Monday the 20th of September, then I will make sure the practice exam this coming Thursday. Remember, there's a practice exam on the 23rd. So if you need cin.ignore on the real test, I will make sure it's on the practice test too. Such a nice guy, this professor. Okay. Anyway, so getline sin full name. Okay. Now, technically, we do not do getline this way, but there's lots of ways you can make anything work, and I know how to make things work. So I did this just so I can demonstrate to you very, very easily with literally just this one statement, and then this is the second statement, and then this is your coot, which is not even, I mean, it is a statement. Oh, sorry, not the return. So 3 statements basically. Well, 4 if you want to count the variable. All right, so not much. So anyway, that's where we are now. So I will put my Catholic background on this table here. So John, Joseph, yes, another J, James, Maloney. All right. So now when I enter that, my getline sin, C-I-N, meaning it's getting it from C input, is going to all be assigned to full name. Okay. And then where it says your name is, see, it's full name. And this is, like I said, a shortcut. This is really not a good way to do this, but I mean, it does work for demonstration, simple demonstrations, okay? In chapter 7 or chapter 8, we might do more with getline. I forget now, because I only teach this class every fall. I teach it twice every fall. But anyway, so that's what we have here. But all those variables, well, it's one variable, but the spaces, in other words, didn't interfere with it. Whereas if you had a variable called first name and you typed John space Joseph for it, the only thing that would go to first name is John, because spaces end all input from the user in a C input statement. And that's what the ignore is talking about. All right, anyway, so that's that. All right. All right. So now I'm going to have you guys copy this. The part on the right's not really, I mean, it's important, obviously, but you guys can do it. So go ahead and take a picture, if you will, from line 1 to line 23. You have 30 seconds to do that, okay? All right, you have 15 seconds to do that. I should have deleted that space up here. Shoot, sorry. I really could have deleted a lot of spaces, but I do it really, you know, again, white space. Remember, they tell you white space is actually good because it helps you to focus on not everything all at once. But anyway, so that's down to 23. So now I'll go up to 24, well, which is a white space. Well, I better leave the white space in. Otherwise, you'll say, wait, I missed a line. All right, so 24 down to 48, okay? So 24 down to 48. And 15 more seconds on this one. So get your camera out. Okay, 5 more seconds. So that one went to 48. So now I'll go to 49. 49 is another space, but I'll leave it. Oh, okay, this one ends it anyway. So 49 now to 68 ends it. So go ahead and take a picture of that. Okay, and make sure you practice this. Okay, make sure you practice this. And on Thursday, even though this is only a recording, but I'm saying it anyway, this is Monday, September 20th. I was going to say October. Monday, September 20th. In class tomorrow, Tuesday, September 21st, I will remind you, but now it's in this video too, that you have a practice exam this Thursday, September 23rd. You do not submit it to me. I will not take it. I will not grade it, but I will include a grading rubric for you to sort of grade yourself. And then you'll also get a grading rubric in your real exam, which is on Tuesday, September the 28th. Have a great day. I'll see you in class day tomorrow. So I'm going to stop my, oops, let me go to here. Stop my recording.